Almost every single piece of a building today, it's just plucked out of a catalog. Things like curtain walls or even structural panels, doors, obviously windows, everything is part of a pre-manufactured system. The challenge then is just kind of putting all these things together efficiently and in ways that ensure a longer building lifespan, and hopefully it just looks decent. If you're familiar with gingerbread houses, they're made like that too. And if you know anything about them, you know that the icing is the stuff that's doing all the work that's holding everything together. The icing creates the illusion of a precise, custom joint between the pieces of the delicious goodness. For buildings, that work is done by this, caulk. This goo and its silicone-based sealant cousins fills every crack and every crevice in all of our buildings today. And in so doing, it keeps this collage kit-apart strategy going, and it seals our fate, guaranteeing that all of our architecture stays flat, killing any possibility for local character and erasing centuries of craft traditions and know-how. To understand exactly how, let's look at the way that buildings were made before our reliance on caulks and sealants took hold. This is how a window would have been put together in Chicago about 100 years ago. This architectural mock-up has a structure in the middle that's made up of brick and steel. Meanwhile, the exterior is lined with blocks, and those blocks are made of terracotta, and on the inside is lined with wood or plaster. As the architect designs a building like this, they know that if the window were to just sit directly on the brick, it would never be straight, and it would leak all the way through the gaps. So they draw in a series of clever accommodations here. Instead of just meeting the window with a single line in the drawing, they draw a sequence of multiple lines. And they do this in both the elevation as well as the plan and the section directions. Each line that the architect draws represents a place where the building could shift in depth, and it offers a place for materials to overlap with one another. From the bottom, the profile goes out, and then in a little bit, and then out a little bit, and then in a lot, and then in a lot again. And the small deviations occur within the block itself, while the bigger shifts happen between the different tiles, and this corresponds exactly where their locations can and cannot be controlled on site. So we know that each block is pretty close to being exactly correct because it's made in a factory, while the shift between the blocks is actually controlled by the folks who are assembling the building on site. And in this way, these lines offer a sort of partnership between the architect and the craftspeople who will ultimately be putting the building together. During construction, they'll be presented with a rough opening, and that might easily be varying by various degrees away from ideal. And each line that was drawn by the architect, or the shift and overlap in the construction, offers them an opportunity to be able to make a decision about exactly where each terracotta tile should go on the exterior. And on the interior, the craftsperson measures the opening, cuts and sands, and finishes each and every single piece of wood in its place. And all of this builds out from a condition that is not ideal or all that precise to begin with, and it turns that into an opportunity. The sequence of lines leaves room for creative problem solving on site, presenting ample opportunities to bury imperfections, while at the same time creating elaborate rhythms of shadows and light on the facade. And it turns the occasion of the window into an ornamental display, born from the process of the construction, and this all leaves a visible imprint on the building and its design. Even if you have no idea what goes on inside of this wall or how it's being held up, you can just look at it and readily appreciate the role that human labor played, or the creativity of the architect, or the craft that went into it. This is the role that ornament traditionally plays in a building. That's in addition to providing opportunities to just make the building unique in and of itself. Because ornament is where local traditions evolve, and they evolve into repeated solutions for building problems that commonly arise inside of a particular location. Creative and effective solutions in a particular area rise to the top, and this makes this place lovingly unique. Even in this skyscraper window that we were just looking at spawned critical conversations about whether this detail should emphasize the horizontal lines of a building's or vertical ones. Ultimately, the vertical lines won. And this kind of local fascination extends to solutions for dealing with all kinds of things, even things in the building like airflow. If you think about igloos or the Truly House of Italy or even shotgun houses in the American South, the entire building layout was all about how the air flows through the entirety of the building to keep everyone cool or warm despite the harsh climate. But none of that can develop without paying attention to how air moves through a building or the joints and the seams between the different elements. And that's exactly what caulks and sealants offer. They turn all that thought and all that care about airflow and joints and how things go together, and they boil it down to a single chemical-filled line. Instead of a celebration, we get the part that no one wants to talk about or think about, and it's visibly masked, and inevitably, it's the part that's the most prone to failure. And that's a recipe for a design that barely considers when or where it's located, and a cascade of consequences follow out from there. That's exactly what's going on here, the United Nations Secretariat building in New York. It was designed in 1949, and that's about 35 years after the terracotta detail was the norm. And the goal here was for this design was explicitly to create no connection with any specific place or time. And it had a reason. That's because the panel of international delegates and architects believed that this placeless and timeless approach could provide an unbiased platform for this new international agency whose mission might be compromised if it's perceived to favor any regional affiliations. So that placeless mission was also accompanied by the fact that they wanted the building to be as visually transparent as possible. If the building ended up looking too closed off or secretive, people might view this newly formed agency as some evil entity deciding the world's fate from behind it in the shadows. However, they also believed that the interior environment should also be fully and completely controllable by occupants visiting from around the globe who might have different preferences related to their customs and where they came from. So from a technical point of view, that's an utter paradox. They want full visual transparency in the facade, while at the same time, full opacity to things like air and temperature fluctuations. For these contradictory goals, seams in the building become the enemy, or at best, a necessary evil. The seams and joints, that's where air tends to get through, and that spoils the illusion that the inside could just be anywhere, and it's where vision is inevitably blocked by opaque materials. The earlier terracotta example created more seams than was absolutely necessary to be able to solve the problem that was presented by a window. But here, where the seams are a liability, a new solution would have to be required, one that cannot, by definition, celebrate the joints and the seams. This is how the curtain wall was born in New York. Curtain walls are when the facade hangs off of the side of the building, rather than filling in the spaces between the projecting floor planes. Hanging that facade surface off of the edge means that it's not disrupted by each floor, and this creates the most continuous, unbroken surface possible. Rather than considering how pieces stack with depth and overlap, you're only able to consider how things relate side by side. The solution is a series of independent panels, in this case made from aluminum, glass, and gasket materials like neoprene. This maintains strength and transparency while also being lightweight, because weight is now a real concern, because these panels need to be lifted into place, and they're hanging off the side of the building, where added weight presents a lot of structural challenges. Each section in this building is 4 foot by 12 foot, or 1.3 meters by 4 meters. The aluminum frame was constructed nearby in Long Island and then was trucked over and installed. Ironically, the first ones that were made and tested, they were actually too heavy for the design of the building and they had to be replaced. So there's a sweet spot in how big the panel should be. It needs to be large enough to justify building this thing off-site, but it also needs to be small enough so that it can be trucked and installed easily on site. In addition to that strange limitation that has almost nothing to do with the building design itself, the entire process ushers in a completely new paradigm and a new set of requirements for the ideas of precision and craft. Because this building alone requires 5,400 copies of these panels to cover the 7 acres of the east and west facades. At this scale, any single tiny error in the manufacturing process gets copied 5,400 times. And when you put those all together, that error compounds and it accumulates. If each panel was off by only 1 degree, then when you stack them 40 stories tall, this is what would happen. While this factory-made approach likely means that each piece is more precise, you still have to account for the possibility that it isn't just perfect. And that's why you have to leave this little gap between each and every single little piece. What this gap does is that it prevents the possibility of these compound errors from accumulating, and it also absorbs any material or building movement over time. And all of this has to happen within a facade that is only 8 inches or 20 centimeters thick. Without overlaps or shifts or layers of any kind, the facade is merely a membrane, with each panel acting sort of like a cell next to other cells along a surface. This building, it was even discussed as if it were an organism, and this was a popular metaphor at the time, so that idea that it's a cell was actually really intentional. In fact, it's how the term organic architecture originated. It didn't have anything to do with sweeping curves or the way that we might use it today. It had to do with the idea of thinking about a building as a singular organism. And even Frank Lloyd Wright spoke about it that way. But boy, did Frank Lloyd Wright actually hate this building. He called it a deadpan box. And unfortunately, the building also became connected with him in another extremely unflattering way. Because Frank Lloyd Wright became known for how profusely his roofs in his buildings would leak. And unfortunately, this building too became known for just how badly its facade would leak. It was so bad and so immediate that it almost caused an international embarrassment and almost undermined the entire mission of the UN. The UN was trying to control the role of technology and the way that it was being used in the world at the time, and they couldn't even control the technology of their own building. They brought on an MIT professor, Albert G.H. Dietz, to specifically oversee the choice and the usage of caulking compounds for the building, because it was these compounds that were identified as the source of the problem. And after his work on this, Dietz became one of the most prominent voices championing these kinds of materials and describing adhesives and sealants as essential tools for what he called component construction. Dietz also explored buildings that have almost no joints and no seams whatsoever, like with the Monsanto plastic house at Disneyland. But by the 1950s, component construction, or assembling standardized units into non-standard buildings, was quickly becoming the dominant approach. And it depended entirely on field-applied caulks and sealants to bridge the gaps, to dampen vibrations, and to handle thermal expansion and contraction. It also promotes the mentality of only considering a single dimension in the building at a time, sitting products next to one another and barely dealing with the joint that goes between them. The adoption spread rapidly because it was cheaper and it was faster than traditional methods of construction. Why would you ever carve a precise joint when you can just slather on a chemical fix? The results are everywhere. It's not just the big buildings and cities, but it's the stripped-down aesthetics of suburban strip malls or those ubiquitous 5/1 housing buildings that are everywhere. But as the Secretariat showed, these systems are only as good as their weakest link. And usually, that's the caulk seam. Yet for some reason, rather than from learning from these problems, we doubled down. It doesn't really matter the scale or the size of buildings anymore. The ethos of design and construction is pretty much the same. Architects and engineers leaned in on sealants to be able to reconcile the imperfections of prefabrication, instead of relying on crafted on-site solutions. While the curtain wall industry were early pioneers in this kit of parts and catalog-style approach, it's now the norm for almost everything. Today, caulks and sealants are a $76 billion global industry.
The caulk aisle. So many choices.
The US alone uses 500 million pounds annually. That's enough to fill a normal-sized caulk crack that wraps around the earth 100 times. Sealants are essential for modern construction, but they've also become a crutch. Builders rely on them to mask imprecise cuts and poor craftsmanship. Instead of designing for durability, we design for disposability, trusting chemistry to solve problems that used to demand skill and care on site. In my eyes, caulked seams are the equivalent of taking all that ornament that we love on buildings, sanding it off, grinding it up, only to fit it into a tube of caulk and then squeeze it out with a caulk gun. Fittingly, the inventor of the caulk gun was said to be inspired by the guns that cake decorators were using for the icing that they would put on cakes and cookies. So that original gingerbread analogy is not as far off as you would think. And this gingerbread house approach has hefty aesthetic consequences on the way that we design and build our buildings. Flat, caulk-dependent buildings, they age poorly in ways that don't look good, and the caulk is expected to be the first thing in the building to need maintenance. And while that's okay because we understand it going into it, what that does mean is that those joints need to be exposed so that they can be serviced easily. Imperfections like dirt and grime stick out like a sore thumb on our smooth facades, but then it also gets trapped in the caulk and then runs down the buildings. And when sealants fail, they do so catastrophically. All the water just kind of comes rushing in. and this can snowball into major structural issues if it's not accounted for. The UN Secretariat building needed a $2 billion renovation after the steel brackets began rusting away because the caulk failed and it leaked into the building. The architects tasked with assessing and fixing the building described it as smeared with every variety of sealant that had come along. These chemicals are tested in labs, where it's next to impossible to be able to simulate real-world conditions. So that leads to lifespans that are often well under advertised levels. And the problems don't end there. They also seep into the air of the building. And I'm not even talking about all the lawsuits and human lives that were lost because of the asbestos that were in the early caulks that caused diseases like mesothelioma. Instead, I'm talking about how caulks and sealants, they offer a promise that our buildings will be sealed more fully. And that ensures that no air can enter or leave without being invited to do that.
You have to nail it shut! There's hammer nails! By the door!
That too is now the expectation and the condition that our air handling systems require. And while this is more energy efficient, it also has a cascade of challenges that need to be balanced out against that. Tightly sealed interiors, it traps pollutants inside and moisture, and that can lead to mold and stale air and higher concentrations of chemicals inside of our buildings. So solving one problem, eliminating drafts and creating the ability of the inside of our buildings to be completely separate from the outside of our buildings, creates poor air quality sometimes. And that drives demand for mechanical ventilation to supplant just the natural airflow, which requires more air filters now and even more chemicals. But ultimately, caulks and sealants, they're not exactly the villain here. They're just tools. And I don't think that modern architecture should be the scapegoat either. I already mentioned how Frank Lloyd Wright, who was a modernist, was opposed to this entire building and process. Even Le Corbusier was on the design team for this building, and he was an outspoken critic of this facade system. And he argued that the thin glass facade was not appropriate for New York. Of course, he was right. But that building wasn't really designed for New York. It was designed for everywhere. And this is the model that we've chosen everywhere. And it's the model that we've chosen to continue on with, making buildings for everywhere instead of where they are. We've traded layers of meaning and layers of craftsmanship and regional identity for thin, mass-produced sameness. By smoothing over our joints and our seams with caulk, we've rewritten our relationship with buildings. It's not that caulk is bad. It's more like it just seals out opportunities to make anything that's cooler, like a terracotta window. This one, for instance, it's in the Railway Exchange building here in Chicago. It's where we filmed that wind tunnel video with the firm SOM. Well, we've since partnered with them, and this building is now home to us and our new studio space here. And we've been cranking out all kinds of content, like a behind-the-scenes tour and my nerdy architectural theory about how the show Severance. I really think that there's something to how the Lumen building, which was designed by Eero Saarinen, sucks people into it. Meanwhile, the Frank Lloyd Wright building, which is Mark's sister's house, pushes you out into the landscape. That one will be on YouTube in just a few weeks, but the tour one, that's a little bit more unscripted and a little bit more personal. But you can watch both right now ad-free on Nebula. Nebula is a streaming platform for high-quality, engaging educational content. That's because we, the creators, we built it from the ground up to be a tailor-made place for providing the greatest viewing experience. I think it simply offers the best proposition for viewers like you and creators because we believe in the value of what we're making. And we're investing in raising the bar for the over 150 creators that are a part of it. People like Neo and Wendover Production, all your favorite creators are there. Some of them are partnering to produce entire shows that are exclusive to the platform, and we've just added a ton more. I can hardly keep up. My favorite is Neo's Underexposure, though, if I can give you a little hint. It's where Neo takes us inside world events in the most mesmerizing way possible, and the only way that he can do. We've also updated the entire website layout so it's more intuitive, and there's also a brand new news section for smart takes on today's news when we really need it. You can gain access to all of this for 40% off just by clicking on the link on the screen. And it's also listed at the top of the description below. From there, you can sign up for whichever makes sense for you, from monthly to annual or to lifetime even. We also offer gift cards, which I think is the perfect way to trick your friends and family to learning a little bit more about architecture. Or if they refuse, maybe they could learn about anything else. So unlock the entire catalog of treasures of your favorite creators and help me continue to share videos with my takes on the buildings that structure our world. See you over on Nebula, and as always, thanks for watching.